ID, the Future, a podcast about evolution and intelligent design.
Welcome to ID, the Future. I am your host, Brian Miller, and today I'll be interviewing Rabbi Aaron Zimmer and Rabbi Elie about their podcast, Physics to God, which can be found at physicstogod.com. These individuals are very, very interesting, so this is going to be an exciting conversation. Now, both of our guests have extensive rabbinical training, and Rabbi Zimmer has also trained in physics and has studied mathematics, philosophy, and psychology. And what's particularly interesting is he traded commodities for several years by applying a method for analyzing the Talmud, which led to great success. And Rabbi Feder has a PhD in mathematics and has published several articles on graph theory. He also has published the book Gematria Refigured, which explores the significance of fine-tuning in Torah, life, in physics. And I'm just going to read a description of their podcast right from their website. The podcast, Physics to God, is a guided journey through modern physics to discover God. We start from the fine-tuning of the constants of nature, travel through the multiverse, and ultimately arrive at a compelling idea of God. I want to thank both of you for coming on our program.
Sure. It's been a pleasure.
Happy to be here.
Well, great. Well, I want to start first by learning more about both of you. So could you please tell our listeners more about your backgrounds and the story of what led you to start this podcast?
Sure. So when we'll first tell you a little bit about ourselves. So I grew up in a home which had a strong value of religion and science. My grandfather was a rabbi and a chemist. My father is a rabbi and a lawyer. My early upbringing was a strong balance between the two. I was never raised in a way that there was some sort of a conflict between the two, but it was always both were very important to me. And as I was studying in college, I decided that I wanted to become a rabbi, but I also wanted to be involved in science and mathematics. And that being the case, it was only natural to me that while I was pursuing my rabbinical training, I also went to a graduate school in mathematics. I got a PhD in mathematics in something called grade group cryptography. And now my field of research is graph theory. And throughout my years, currently, actually, now I'm a professor in a local college, a math professor. And I'm also a rabbi, and I teach classes in a local yeshiva. And I teach Talmud and the Bible and other topics. And I've integrated my love of God, of religion, together with my love of science and mathematics. And that being the case, again, Rabbi Zimmer, Aaron, and I have been studying a lot of Talmud and have been studying Bible and have been studying science and mathematics and a lot of discussions over the years.
Well, that's fascinating. Could you share more about yourself, Aaron?
When I was growing up, I had this dual curriculum of learning religious studies in Judaism and also secular studies, math, science, English, things of the nature. And for me, there was always this tension between the two worlds. And I think a lot of people in the modern world have this, that there's almost like a battle, even if it's in the background, it's always there, that there's some conflict between religion and between the modern rational scientific world. And as I grew up, I had to make decisions. You have to choose what you believe. And I know a lot of people are able to, in a certain sense, dichotomize their life the way they think, where they have certain categories they approach religion, certain categories they approach secular studies. But for me, that just was never really a viable option. I always felt I wanted to be an integrated, unified person, and I wanted to find a way of reconciling them. And eventually I was able to, through my teacher, Rabbi Chait, and open my eyes to a way of viewing Judaism in a rational way and a way of interpreting and reconciling science with Torah, with religion. And I pursued science really for its own sake, to understand the wisdom of God in the world. I got a degree in physics, and I was always looking for ways to ground my beliefs in rational arguments and rational justifications. And eventually, when I'm sure we'll discuss more, that led me to this, Physics to God, the podcast, this whole story. We started to write a book, but it really led me to the whole thing was a pursuit of really trying to integrate the two worlds, the secular world and the religious world, in a rational, harmonious way.
And you do have a really nice flow with each other on your podcast. Do you feel like you each bring something special to the conversation? How do you interact with each other? What's produced your really wonderful chemistry?
Great question. So I guess you could start as Aaron really has a stronger background in physics than I do. And he kind of got us into this area in the first place. He reads a lot of physics. I also do, but he studied it in a more rigorous way than I did. And, one day he kind of said to me, Elie, it's unbelievable. I'm reading this book by Elie, and this unbelievable. It provides an argument which supports the existence of God, and we gotta pursue this. So that's kind of how things get started. But I guess what Aaron brings to the table is he's in the details of the physics. And again, I'm familiar with physics and mathematics and philosophy, and we argue these points out. And one thing which I think I bring to the table, and it creates like a nice balance between the two, is I'm a professor and I teach math in a community college. And that being the case, my students are often the types of students who never quite understood math. They're afraid of math. And they certainly would be afraid of physics if I even try to mention it. And that being the case, it's like my job on a daily basis to try to get through to students and to get through to them on a level that they could understand. And therefore, in a certain sense, when Aaron and I discussed, there's a back and a forth. The project started out as we were writing a book. So we had a blog, and then we ended up making it into a book, and then we decided to make it into a podcast. And basically, there's often a tension where Aaron is trying to present the material on a higher, more rigorous level, which I appreciate. It's important to be rigorous when you're dealing with these areas. At the same time, I appreciate the fact that our listeners, our like students, or people who are listening to our podcast may not be able to really take in the physics, or maybe scared off. So I kind of try to make it simpler, and then sometimes Aaron tries to make it more rigorous, and I try to make it simpler, and there's like a back and a forth, and that's kind of the way we've been developing these ideas over the years, in that type of way.
Yeah, I would just say one thing is that we've had this argument for 20 years. I think it boils down to one thing that, like, I feel that when you say an idea, you should put the onus of responsibility on the listener to try to use their mind to understand what's going on. And it's beneficial to them to not just spoon feed them, break down everything into little bite-sized pieces. Let them think, let them try to understand. And when even if it's not so simple right away, but by them engaging their own minds, they end up acquiring the knowledge in a much deeper way because they work to understand it. While Elie feels like the onus and responsibility is on the speaker to make it as clear as possible and as simple as possible, and give an analogy and give a summary. And I'm always like, Elie, why do you got to make a summary? Why do we have to repeat what we just said? Why do you got to use an analogy? It's simple, it's clear. Like, let them think a little bit. So, we basically have had this argument for many years. We both teach. We have students. I'd say most appreciate Elie more. Most people appreciate Elie more. They like it when it's fed to them and spoon fed to them. And I don't think it's the best thing for the student. I think it's students like that. People like a listener wants to hear it simply, and they don't want to have to work. But I think that they gain more from working. But we fight about these things in a podcast. Usually Elie ends up winning, and we do it because most people kind of agree with him. I recognize that. So we kind of do make it simple on the podcast and summarize things and make analogies. But I'm always in the background there trying to make it a little more complicated.
I think it is important to have Aaron's part also, because again, when you're dealing with, there's a danger of oversimplifying things, and anyone could argue for the existence of God if you want to oversimplify things. These things are complicated, and physics is hard, and to just gloss over all the details and not get down to the hard science is also a mistake. So I think that's why we have the back and forth.
Well, I like the balance you achieve, because on one hand, you do make it accessible for lay people, which is very valuable, but then you also will inspire people to greater heights by challenging them to think deeper. So I think it's a very beautiful balance that you have. And I remember one of the most valuable experiences I had was teaching 5-year-olds for my church. And that forced me to explain things really, really simply. So now I've been able to speak to audiences that include junior high students, but also occasionally audiences that include Nobel laureate physicists and, world leading chemists and things like that. So I greatly appreciate that balance you've produced. Now, along those lines, what is the general content of your episodes, and really who is your target audience?
Okay, so the overall content of our argument is that we present, as you read, as you had in the description, where we're basically presenting an argument based upon discoveries of modern physics, specifically discover something called fine-tuning. We'll talk more about soon. Discovery to show how these modern discoveries lead to the existence of God. they point to show you that in a sense, like there's an intelligent cause for our universe. And that's basically the overall picture of what we're trying to do. But we do that through a lot of slow process. Because again, as physics is hard, people aren't familiar with it. So we try to each episode builds a little bit more, and we develop an argument, a step-by-step argument, which ends up leading the listener to be able to see for themselves the fact from modern physics, the fact that God exists.
There's also, that's like the first series. We're almost done with that. We've released, I think, the first 7 episodes. There's probably going to be about 10. In that first series, that's intelligent cause, showing how there's an intelligent cause. We're going to have 2 other separate series, one about the multiverse, which is what, again, we'll probably talk about that more later. That's physicists' response in a certain sense to all these arguments in general. There's an infinite number of unobservable universes with all different laws of nature and things of that sort. So we're really going to have to take that up seriously and break it down, show that it's what it needs to prove, and show whether, do they prove it? Do they not prove it? Are there any problems, logical foundations, which we think there are at the very foundation of multiverse theory. But that's also going to be a separate series. And then our third series is going to be about God and the idea of God, answering questions about what caused God, what does God even mean? Who designed the designer? There are a lot of people you say you give a whole argument for God fine-tuned the constants, or God designed this, God designed that. But then people ask you, who designed the design? You have to be able to answer these questions, and there's much more. The classical questions on God, and you have to have a clear definition, a coherent, logical definition of God, or else you haven't really accomplished anything. Then and then you just you've shown a lot of problems, but your solution is no better than all the problems. So we're going to have another separate series, probably around the same 10, 12 episodes about God. And those 3 are essentially what we plan on doing for this podcast, 3 separate series.
So about our target audience. So I guess we kind of narrow it down to 2 classes of listeners. One is religious people who, as Aaron was discussing before, who embrace their religion, but they also embrace science. And they're kind of confused, perplexed. They feel like, in a certain sense, it often seems like these 2 are in conflict. I think scientists often present it that way. They often present it that, well, if you believe in science, then you can't believe in God. And we're trying to show that, on the contrary, it's not only does science disprove God, but on the contrary, modern discoveries lead to the existence of God. So we think that a lot of religious people struggle with these. The world certainly tries to paint a picture that God is outdated, and we're trying to talk to those people and show them whatever religion they may be from. We don't get into any specifics of Judaism or any religion. It's very much about the existence of God, who's the foundation of any religion. So that's kind of our first target listener.
Right. Our second one is, and maybe this is a pipe dream, but we think that there's an open-minded secular person who's just, willing to hear about the possibility that you can have a rational philosophical argument based on science that can point to the existence of God in a clear, convincing, compelling manner, which we think we do. We think this is far and away the best argument that we've ever seen. I think it's better than a lot of the other arguments that people use out there, and this is really a convincing argument. And for somebody who's open-minded, if you just come to the table without any preconceptions, our podcast doesn't assume religion, it doesn't assume revelation. We never mention any of those things. Any providence, we're not involved. We're really just trying to show from science, if you have an open mind and you use proper philosophical reasoning, you will arrive at a very clear and convincing idea that there is an intelligent cause for the universe. And we'll define that idea of God. And, we don't know how many of those people there are and how many we'll be able to reach, but that really is, part of what we're trying to do is for the secular person who's open-minded to give them something that's really solid and rational justification for believing in the idea of God.
That's fascinating. So what you're hoping to do is really help people to realize that there really isn't this conflict between faith and science, but the science through a rational lens points to a designer. Is there any other hopes you have for people listening to your podcast? Like after they listen to your podcast, would you like for them to do anything else or explore it even in more depth?
The one thing we'd like to do is that besides for the arguments leading to the existence of God, we think that through studying the physics, through studying what we're going to talk about, fine-tuning and the laws of nature and something called initial conditions of our universe, we hope to give the listener a feel for the wonders of the universe, the wisdom in God's universe. And we really think that The idea of love of God is a person who sees the wisdom of God is drawn to be able to understand more of what God created. And that's what we hope to inspire people, to enlighten, to show the unbelievable wisdom that's built into the very fabric of the universe from its very inception.
Well, that's really inspiring. And now what we can do is let's talk a little bit about the actual content of your episodes. And in your early episodes, you discussed the constants of nature. Could you explain what the constants of nature are and why are they important to discuss?
So the constants of nature are the quantities in the laws of nature. So, for example, let's take a law of physics. Let's like electromagnetism, which is that two electrons, two negative charges would repel each other. So the question is, how strong is that force between them of pushing them away? That's a quantity. That's a number. That's an amount. It's not a quality. The quality would be opposite charges attract and same charges repel. But the quantity was called the fine structure constant. And that quantity can exist in quantities exist everywhere in nature. The rate of expansion of the universe, how quickly is the universe expanding? Something called the cosmological constant. So there are about 25 of these numbers. Most of them come from quantum mechanics, but one comes from general relativity. And there are these specific numbers and values that are built into the very laws of nature. And they're always the same everywhere. And that's why they're called constants. So how heavy an electron is, its mass is a constant. The strength between two electrons, that's a constant. And since they're the same everywhere, these numbers, these values, they're called constants. And they're incredibly important because you can't have qualities without quantities. You can't just say there's a force of gravity of two masses attract without telling me how strong they attract. It's everything in the universe has to have, besides the qualitative description of its laws, it has to have a quantitative description. And these constants are the numbers that set those values.
You want to say what these numbers are? I wanted to point out that these numbers are not like numbers like 3 or 4 or even pi, but the numbers are strange looking numbers, like the fine structure constant. I don't have it in front of me, but it's like 137.139999047 or something like that. Or the cosmological constant, which is the rate at which the universe is expanding, is something like 3 times 10 to the negative 122nd power. That's 0.00000, 121 zeros and a 3. So these numbers they're very strange numbers, but these are fixed numbers that are built into the very fabric of our universe. And in a certain sense, when scientists try to understand the universe, this is kind of the goal of scientists, is to try to take all the phenomena which we observe and try to simplify, unify. There's a search for something called the final theory or a theory of everything, where they're trying to understand everything in terms of certain basic laws. And they've been largely successful at getting it down to general relativity and quantum mechanics, are these two qualitative laws, which everything else in a certain sense emerges from. But these two laws, sets of laws, have these constants. These numbers are like seemingly built into the very fabric of our universe. And there's a quote from Feynman where he says, or Richard Feynman, where he says, like, explaining these numbers is one of the greatest mysteries of physics. Where do these numbers come from? He's specifically talking about the fine structure constant, but he's saying in general, these numbers, where do they come from? What's the cause of these seemingly arbitrary numbers? Where does scientists try to understand everything, to explain everything and break it down to simpler and simpler? And we get down to the basic core of our universe, we end up at just these seemingly arbitrary numbers. And this was a mystery. It's a mystery from Feynman's time. This is in the book QED. I think it's 1985 we wrote it. But basically, it's a mystery, going back. Nothing to do with God, nothing to do with fine-tuning, nothing to do with anything. It's just a mystery. How do you explain the values of these numbers?
I really appreciated you mentioning Richard Feynman, because he is an amazing physicist who was one of the most thoughtful thinkers about the big picture of science. And he was a great communicator. So I really loved that you brought that in one of your episodes. Now, in later talks, you talk about what's called the fine-tuning of the laws of physics, and that deals with these constants. Now, would you please explain the idea of the fine-tuning and how it relates to these different quantities and constants?
So this is really the key idea of presenting the whole argument. A lot of times people start with fine-tuning, and they think that the problem is fine-tuning. That's a mistake. Fine-tuning is not the problem. It is the clue which points to the solution of the constants. So the mystery of the constants, which Elie just explained, that's the real problem. How do you explain these 25 numbers? You want a theory of everything that can explain everything in the universe. But how does a theory explain 137.035999139? What qualitative theory generates that number? It seems impossible to come up with it. That's the mystery of the constants. But then fine-tuning is this clue. Fine-tuning means that when we study these numbers, they're not just these random numbers. They're not arbitrary. If 137 seems like this arbitrary number, it could have been a million. It could have been 214.392. It could have been anything. And you say it's 137.039, that seems like an arbitrary number. That's a mystery. Fine-tuning says that only if this number is within a small range, like let's say between 136 and 138, something like that, a small range. And if it was any different, there wouldn't be atoms because this number regulates the strength between two charges. So let's say a proton and an electron in an atom. And the reason that atoms are stable is because the fine structure constant is this specific number, 137. If it was different by about 5%, or if in one direction or the other, there wouldn't be any atoms. There's not going to be any molecules, not going to be planets and stars, and you're not going to have any of these things. So what fine-tuning is basically it shows for all these constants that, in a sense, scientists overlook something initially. I mean, scientists discover fine-tuning, not anybody else. But initially, the whole problem when Fein was discussing the mystery was by not realizing that they're not arbitrary numbers, but they have to be within a specifically small range in order to produce a certain result of having atoms and molecules and planets and stars and galaxies. And if they were slightly different, you wouldn't have any of that. So it's a clue to show you that the significance of these numbers, it's knowledge about the numbers, how they're incredibly important in order to produce a complex ordered universe.
Right. Just let me provide an analogy, and we talk about this on our podcast. This idea of these numbers, because again, I think people have a hard time with physics, and they're not so accustomed to laws, qualitative laws, and constants, and it's perhaps scary to some people. So, analogy we describe is imagine you have an ethical system. Right? I mean, any society has an ethical system. The ethical system might have a number of laws, like you're not allowed to steal, you're not allowed to cheat, you're not allowed to kill, you're not allowed to charge interest, you have to give charity, and so on and so forth. And you could have many laws. And if someone is trying to understand the core of this ethical system, which may have tens of laws, you might come to a principle and say, we're looking for an underlying theory which unifies them all. And that underlying theory might be, do unto your neighbor as you want unto yourself. And that would be like a law which underlies all of those different laws. So all the laws could be an expression of that same one law. But within these laws, which we're trying to explain, you might have, for example, you have to give charity. So imagine it says you have to give charity of 13.8743226%, where you're not allowed to charge interest of more than 18.70364%, something like that. So those are the idea of what we mean by quantity. So laws don't only have qualities, give charity, but they also have a quantity. How much? Part of the mystery of the constants was that the quantities which are built into these laws seem to be totally arbitrary. It's not like give charity 10%, but it's like the numbers it's totally hard to understand. And how in the world do you explain numbers like this? You're trying to understand the fundamental building blocks, principles which underlie our universe, which underlie this ethical system. We would be stumped by finding numbers that were so far out there, so strange. And the discovery of fine-tuning, in our analogy, would be like, let's say we were to study the economics of a society, and we'd realize that if the amount of charity were too high, then richer people wouldn't work because they say, listen, it's not worth it. We're going to have to work so hard. We're going to have to give so much charity. And on the other hand, if the amount of charity were too small, then poor people would be upset and they'd fight and there'd be class warfare. And if, let's say we were to discover through rigorous economics, mathematics, which again is not reasonable in these areas, let's say we discover that if the rate of charity had to be somewhere in the ballpark of 18.3467%, if it were too far off of that, we wouldn't have a stable society. And that's kind of the idea of that would be an indication that this number is fine-tuned. But it's not too high, it's not too low, it's just in the right point, which allows for the future, for the emergence of a type of a society which we're looking for. That's kind of the discovery of what fine-tuning is showing us. These numbers are not arbitrary. They might look arbitrary, 137.139 or whatever, might seem arbitrary, but science has discovered, and again, this is discovery that theists, atheists, everyone agrees is discovery, Fine-tuning is that if the numbers were different, were a little bit off, and if they weren't in this small range, our entire universe, atoms, molecules, stars, galaxies, life, everything wouldn't exist. And that's what we mean. That's the discovery, which kind of is a clue to solving the mystery of the constants. What are these? What's the cause of these numbers? It certainly has something to do with fine-tuning. These numbers are not arbitrary, but they're special values, which are only those values which will allow our complex universe to emerge.
That is a beautiful analogy. I mean, that and I can see how your rabbinical training really has helped you to make certain connections. That was very impressive. This is the end of part 1 of the interview. For ID the Future, I'm Brian Miller. Thank you for listening.
Visit us at idthefuture.com and intelligentdesign.org. This program is copyright Discovery Institute and recorded by its Center for Science and Culture.